This is a continuation of the square root and cube root lesson. I've already taught you the square roots, so now we're going to talk about the cube roots. So let's skip ahead, and there we go. Okay, so cube root is one of 3 equal factors of a number. If you remember, square root was one of 2 equal factors. Okay, this one's one of 3. So perfect cube is a number whose cube root is an integer. So for example, be 1, 8, 27 are the first 3, for example, because 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. So if I take the cubed root of 27, I'm saying what times itself, okay, would get me 27. So basically, the cube root then would be 3, because 3 times 3 times 3 gets me 27. 64 is another one, 125 is another one, and 216 would be another one. Those are all perfect cubes, which we can then use to make our list of cube roots. This is what you're going to want, okay? So the cubed root of 1, so we're saying what number times itself gets me 1. Well, that's 1, okay? Cube root of 8 is going to be 2, because 2 times 2 is 4, 4 times 2 is 8. Cube root of 27 is going to be 3. Okay, cube root of 64 is going to be 4. Okay. Let's see. Cube root of 125 is going to be 5. Cube root of 216 is going to be 6. Cube root of 343 is going to be 7. Cube root of 512 is going to be 8. Cube root of 729 is going to be 9. Cube root of 1,000, it's going to be 10. Cube root of 1331 is going to be 11. That should get us through most of what we need to do. If you get anything bigger than that, remember you can just take the number times itself, and that'll get you your list. That'll get you your cube root, your perfect cube. All right, so estimate the value of non-perfect cubes. So, for example, the cube root of, let's say, 80. Okay, so if I look back at my list, 80 is between 64 and 125. Come on. 64 and 125. Well, the cube root of 64 is 4. The cube root of 125 is 5. That means the cube root of 80 is between 4 and 5, okay? And which would it be closer to? Well, obviously it's going to be closer to this one, because 80 is a lot closer to 64 than it is to 125. So it's a decimal, 4 point something, 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 closer to 4, okay? Another one, let's say the cube root of, I don't know, let's go, oops. Do that. Let's go cube root of 1112. Okay? So cube root is going to be between the cube root of 1,000 and the cube root of 1331. So it's between 10 and 11. Okay? And which one is it going to be closer to? Well, this one's 112. So it's going to be closer to this one. It's actually pretty close to 10 and a half. Okay, cube root of 12. All right, that's going to be between the cube root of 8 and the cube root of 27. So it's going to be between 2 and 3, and it's going to be closer to 2. Okay, so again, you just take your number. So like if it's the cube root of 480, go back to your cube root list, which you should have written down, obviously, 480 is going to be between these two. Oops, too far. 343 and 512. So it's between 7 and 8, and this one's only a little bit away as opposed to this one. Okay, so it's going to be closer to the 8. Okay, oops, missed one. Decimals and fractions. Okay, same thing as with the square roots, we can split it. Okay, so you can have the cube root of, oh, I don't know, let's go 1/8 is going to be a half. Couple ways to look at that. You can think of, well, a half times a half times a half. 1 times 1 times 1 is 1. 2 times 2 times 2 is, whoa, is 8. Okay? Or you could think of it as this is the cube root of 1 over the cube root of 8. Well, the cube root of 1 is 1 and the cube root of 8 is 2. That's another way to look at it. And one thing I did forget to mention, if it were the cube root of a negative number, your answer is negative. Because a negative times a negative times a negative is still negative. Because negative times negative is positive. Positive times negative would be negative again. Okay? So you can have the cube root of a negative number. We cannot have the square root of a negative number, however. So if you remember on the square roots, our answers were like plus or minus 4. Here it's going to be one or the other. It can't be both answers. Okay? Let's see. So the cube root of 343 over 1331 would be 7 over 11. Okay? And then for your decimals, okay, kind of like in the square roots, first you look for the perfect cube. Well, the perfect cube is 64. The cube root of 64 is 4. All right? And then in the square roots, remember we took how many decimal places there was, or how many place values, and we cut it in half. Well, this time we're going to cut it in thirds. Okay? So 1, 2, 3, 4, 5, 6. A third of that would be 2, so our answer is going to have 2 decimal places. All right, let me do another one like that. That's a 3. Cube root of that. Okay, the cube root of 512 is 8. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 3 is 3. So our answer is going to have 3 decimal places. Okay? All right, real numbers concept map. All right, so real numbers, we can either have rational numbers or we can have irrational numbers. Oops. There are in there. Okay, so rational numbers. That's your counting numbers when you're in kindergarten. What do we learn to count with? Okay, that's our whole numbers. Okay, example would be like, would be like 5. Okay. We have our integers, which basically is your whole numbers and their opposites. So let's throw a negative down there. Okay. Whole numbers, integers. We've got fractions. Okay. So like a half. We've got repeating decimals. Okay, so like 0.4 repeating. And we have terminating decimals. Okay, so that would be like 4.1 when it terminates, when it ends. Okay, so all of those numbers are all rational numbers. So what does that leave for irrational numbers? Okay? That would be like your non-repeating, non-terminating decimals. Okay, so a non-repeating, non-terminating decimal means it doesn't repeat, it doesn't end. That's going to be something like pi. Okay, it's a decimal, 3.1415926. Okay, it doesn't end and it doesn't repeat. Okay, that would be an example of that. Another type of irrational number would be your square roots or cube roots of non-perfects. Okay, so non-perfect squares, non-perfect cubes. So for example, like when we were doing the estimating, like the square root of 50, okay, it's pretty close to 7, okay, but it's going to be a decimal. And then like the cube root of 50, okay, again, so I guess I did the same number. Square root of 50 is going to be pretty close to 7. Cube root of 50 is going to be between 3 and 4, okay? But both of them are going to be decimals that are not nice numbers, so it's going to be your irrational numbers. Okay? And that's it. Oh, by the way, that'll be a test question.